So we're basically comparing two different baseballs. One of the baseballs, they show it on the graph, and then the other baseball, they only give us an equation. So here's my equation for the second baseball. That's g of t, and then the first baseball is this graph right here. So what is something we know about the graph of the first baseball? What is something we know about the first baseball?
The vertex.
The vertex. And where is that?
4,144.
Not 4,144, but
No,
3,144. Okay, so what does that tell me about the baseball? That's baseball number one. So if the vertex is at 3,144, what does that tell me?
that's the maximum height.
That's the maximum height. Good. All right. What's another thing that I know about this first baseball? So the vertex
One
is
of
one.
the x's.
Yeah, the x-intercepts. What are they?
6 and 0.
6 and 0. So what does the 6 tell me?
The total time.
Total time, total air time. It was in the air for 6 seconds. Okay. And that's basically all I need to know. How about baseball number 2? I don't have a graph, but I do have an equation. And what form is the equation written in? What form is this in? Standard form, vertex form, factored form, what is it?
Vertex form.
It's in vertex form. Since this equation is already in vertex form, what does it tell me about the graph?
Oh, I know where I messed it up. Okay.
That's okay.
The vertex.
Yeah, where is the vertex of baseball number 2?
Positive 4,256.
Positive 4, 256. And what does that tell me about this baseball?
It is higher. It has a maximum higher than basketball one.
Yeah, what is the maximum height?
256.
256. 256 feet. So when it asks me which baseball has a greater maximum height, that's going to be baseball number 2 because it goes all the way to 256. Okay, so that's that part. I would expect everybody to know how to do the first part. That's why I said most of you can probably get half of this question correct. So does anyone have any questions on how to get the maximum height and how to compare them? Any questions? Okay, so yes, baseball 2 overall is much higher than baseball 1. And now for the next part, it's a little bit harder to understand. We actually probably after your next topic test, you guys are going to learn how to do this a little bit better. But for now, we're just going to estimate it. There is a way to find out for sure. But right now, all we can do is estimate. Because it's asking me which baseball is in the air for longest. And in order to answer that question, remember, for baseball number 1, we had to look at the x-intercept. For baseball number 2, do I know the x-intercept of that graph?
Mm-mm.
I don't, do I? So unfortunately, we don't have enough knowledge yet to be able to answer it. You will, like I said, you'll learn how to do it after the next topic test. But for now, we can estimate it a little bit because we know that this graph has a vertex at 4, 256. So it's like somewhere like way up here, right? The vertex is somewhere way up there. And A is negative 16. So what does A tell me about the graph?
It's facing downward,
And what type of shape is it going to be?
stretched.
Very stretched, right? So again, this is just a sketch. I don't know for sure if this is what it looks like, but let's say it looks something like this. The vertex is passing through the axis of symmetry. So I know that whatever the x-intercepts are, they're going to be equally distant from the axis of symmetry. So one possibility is that the two x-intercepts are +2 and +6. Now again, this is a sketch. I don't know for sure, but I'm just taking a little bit of a guess. So if those are the two x-intercepts of the graph, how long was the ball in the air?
6 seconds.
But when did it leave the ground?
4 seconds.
It left the ground at 4 seconds and it returned to the ground at 6 seconds. So it didn't start at 0, it started at the 2. So think about it again. How long was it in the air for?
Two seconds.
Not 2 seconds. It started at 2. It went up. It came down at 6. How many seconds is that?
4.
4 seconds. 4 seconds. So which one was in the air for longer?
The first one.
The first one, yeah. Yeah. 6 seconds is longer than 4 seconds. So basically what happens is the second ball, they maybe, like, if you think about it, they started the timer, and as soon as they started the timer, they threw the first ball, but they didn't throw the second ball until after 2 seconds later. So they threw the first ball, 2 seconds passed, they threw the second ball, and they both landed at the same time. But since they started the first ball 2 seconds before, the first ball happened to be in the air for 2 more seconds than the second ball. I know that was a lot of first and second and first, but does anyone have any questions on why that works this way? So the total time that it's in the air, you always have to look at where it started. If it started at the 0, then you can count from the 0. But if it started a little bit later, you have to count from that point. You can think of it as this is my start time and this was my stop time.
Oh.
Okay. Any questions on this problem? Awesome, awesome. Okay, cool. So today we are continuing with word problems. But the big difference between yesterday's class and today's class is that today we are not going to have any graphs. So it's going to be all word problems, no graphs, but we still are going to be answering the same types of questions. So I actually want to add a little page to this. I always forget how to, okay, add page. I want to add a page real quick just to go over the keywords that we started to talk about yesterday and that we will probably see again today. So we're just going to make a quick little list of keywords that we can keep an eye out for. So when we're looking at a graph, there are basically 3 different key features of a graph. We have a vertex. What's another feature of the graph that we always kind of look for?
AOS.
Axis of symmetry. I'm going to lump that in with vertex because they're at the same place. What else? So we always look for vertex. What are some other points that are on the graphs that we've been looking at?
Y.
Y-intercept
The X.
and x-intercepts, yeah. Wow, can I spell? No. Y-intercept, x-intercepts. And sometimes there's one, sometimes there's more than one, but usually we'll see one or two. So for each of these different parts of the graph, we have different keywords. So we're just going to make a little table, and let's do this together. I'm not going to say all the answers. I want you guys to think as well about what words we might have seen before that tell us, okay, we got to look at the vertex. Oh, okay, we got to look at the y-intercept, things like that. So can anyone think of any keywords that usually tell us to look at the vertex? Or the y-intercept or the x-intercept, whatever, if anyone can think of anything.
Vertex, maximum or minimum.
Maximum, minimum. Perfect.
Y-intercept, starting.
Starting, what's another word that they use a lot instead of starting?
Beginning.
There's another one I'm thinking of. Starts with an I.
Interval. No, intervals for X.
Initial. Yeah, initially. Initial. Initially. Good. So those are very, very good words. X-intercept is a little less easy to think about, but let's see if we can come up with any. Okay, good. Yeah. So we know that there's a few words that are synonymous. They are synonyms. So there's roots. What else are those? Let's name those four. Zeros.
Zeros.
Oops, sorry. Roots, zeros, factors,
Solutions.
solutions. Good. Okay. But now let's think of words that are more like word problem type of words, like the baseball goes at an initial height of 4 feet. It reaches a maximum height of 48 feet. And then how do we talk about x-intercepts?
And it stops.
Mm-hmm.
Or it ends.
Yeah, where it ends. So think about it. When something started at 0 and it ended at 5 seconds or 5 feet, that would be there's a word there. How much time was it in the air if it was from 0 to 5 seconds?
Mm, 5 seconds.
5 seconds. So that 5 is my total amount. And sometimes it's going to be total time, total distance. Usually it's time or distance. So those are kind of the two that we look at. So total amount or ending amount, ending value. Kind of like always think about where it ends. So it starts at the y-intercept, it's going to reach the minimum or the maximum at the vertex, and then it's going to reach the end or the total at the x-intercept. So those are pretty good keywords. If we find any others throughout today's lesson, we can go back and add them to these lists. All right, so now take another 30 seconds if you haven't written these down yet, or you can take a picture, and then we'll go ahead and look at our first problem. All right, just about 10 more seconds. Like I said, take a picture, and then you can write it down as we continue. Okay. All right, who would like to start us off? Lots of word problems today. I'm going to call on people otherwise. All right, let's hear from Chloe. Chloe, can you start us off? Chloe, are you there? Can you hear me? No, Chloe? All right, we'll get to her later. How about Samantha?
The height of a ball during tossed into the air can be modeled by the function h of x equals negative 4.9x squared plus 6x plus 5, where x is the time elapsed in seconds and h of x is the height in meters. The number 5 in this function represents.
Okay, what do we think? So first of all, we have, and thank you, Samantha. First of all, we have a nice equation here. What form is that equation written in? What form is this?
Standard.
Yeah, standard form. So remember, whenever you see an equation, the first thing you have to think about is what form it's in, because every form, all the different forms tell you a different thing. So in this case, what does the 5 represent when we're talking about standard form?
Y-intercept.
It's the y-intercept. So the 5 is the y-intercept, and what does the y-intercept represent in real-world examples?
Start where it starts.
Where it starts, and that other word that we wrote down, initial. So that's how easy this type of question can be, because at the end of the day, we're just looking for keywords. We're just looking for keywords, but you have to know what form it's in, what that number is representing when you're in that form. So in this case, the 5 was the y-intercept. And then you think, okay, what does the y-intercept represent in this type of situation? All right, so now I want to look at the other examples because these are pretty good just to know what they mean. So example B, what would that be on the graph? It's not the y-intercept.
Intercept.
Yeah, this would be the x-intercept. Right, because it's telling, it's the when the ball goes back and reaches the ground, that's your x-intercept. How about C?
Vertex.
The vertex. Now, is it the h value of the vertex or the k value of the vertex? If it's talking about time.
I believe h.
Yeah, you're totally right. So it's the h value of the vertex, which means this one, the maximum height, would be the
Vertex.
h or k?
K.
K value of the vertex. And that's simply because, remember, what happens? This ball goes up and then it goes down. Here's the vertex. This is h comma k. And h is the x value. So this is my x-axis. And this is my y-axis. So here's h and here's k. So k is the height and h would be the time of where you are at the vertex. So in general, that's actually something to, like, we can also write this down in our list actually, because usually the h value is going to be time and the k value is usually going to be height. If the question is like they throw a ball or they shoot something out of a cannon or they're diving off of a diving board, all of those situations where they're measuring the height of something and they're measuring how long it takes. If you're talking about time and height, h is going to be time and K is going to be height. So that's another good thing to kind of keep an eye out for. Any questions on that? All right, let's do another one, this time on your own. Answer it in the poll. Very similar type of problem. All right, take about 10 more seconds. This should be pretty quick. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Only 6 people have answered? Come on, y'all, there's 15 of you. I want to see way more responses. Let's go, pick an answer. Doesn't matter if it's a guess. 5, 4, 3, 2. Y'all really want to be cameras on after spring break. Is that what this is about? Remember what we talked about a couple weeks ago. If we keep this up, I'm going to be requiring that your cameras are on after spring break. This is unacceptable. Only 7 people voted. That's only half the class. We need to do way better than that. That is absolutely unacceptable. If I don't see that number go up by the end of today's class, then we're going to be in trouble. And I'm talking specifically more to the people who are at home, because those of you who are in school, I know that it's a little harder with the Wi-Fi. But those of you who are at home, unless you have some issues, and you have to let me know if you have issues, then this should not be what's happening. Okay. We were kind of all over the place, so clearly we need to do a little bit more explanation again. Let's take a look. What is the meaning of the number 3? On
point / initial point and the y-intercept.
It's so in the equation, it's the y-intercept. And we know that the y-intercept is the initial point or starting point. Okay. So is it the amount of time, or is it the maximum height? Does it have to do anything with the maximum height?
Yes.
No,
No, what's maximum?
maximum is h, which is located at the vertex.
Maximum would be the height. The maximum, the vertex, I mean, sorry. That's what I meant. Maximum would be the vertex. That's not what we're talking about. We're talking about y-intercept, not vertex.
So A and D are out because they're talking about maximum.
Yeah, both of these have to do with vertex. Now, there's going to be one scenario, and we'll talk about it in a little bit, but there's only one time where the y-intercept is the same as the vertex. But it's not this case, and we'll talk about when that happens. Okay, then B, the ball takes 3 seconds to reach the ground.
That means it was in the air for 3 seconds, but it's not talking about the starting point.
Right. When does it reach the ground? At what point? What is that point called on a graph?
The x-intercept.
The x-intercept. So it's not that either. It's C. The ball was thrown from a height of 3 feet. That's what we're talking about, because, and you can always kind of sketch it out. We can sketch it out a little bit. 1, 2, 3. That's the y-intercept. If I know that A is negative 16. So what does that tell me about my graph?
It's facing downward.
Facing downward. So it's going to go up and back down. So the y-intercept is the starting point. It's the place where it was thrown from. And what you can think about is maybe like you have a person throwing the ball from this height. Oh, that's a really weird looking person. But they throw it from, they hold it at the 3 feet and they throw it up at that point. Okay, so that's kind of, we got to make sure that when we're reading things, we're reading it carefully. Does anyone have any questions on this problem? So these two were very similar, okay? Y-intercept, if you're in standard form, it's very simple to know where the y-intercept is located and then to figure out what it means. So that's kind of it for y-intercept for today, because now we're going to move on. Well, actually, we'll talk about it a little bit more, but we're going to talk about vertexes now. Okay, I'll read this one because it's kind of short. The function f of t equals negative 16t squared plus 20t plus 4 gives the height of a ball in feet t seconds after it is tossed. Okay, part 1. At how many feet off of the ground was the ball released?
4.
There you go. That's my y-intercept, and that's my initial height. So very similar to what I was saying before, right? If you have a person holding a ball, maybe I'll give him like a little baseball hat so we know what he's doing. There you go. And he's got a ball and he's going to throw it in the air. The ball's going to go up. It's going to come down. And this right here is my initial height. So this would be, no, 4 feet in this case. All right. So the y-intercept, the initial height. Now the word initial is our key word, but they're going to say it different ways. So in this case, they didn't say the word initial. They didn't say the word starting. They didn't say the word beginning. But how do we know that we're still talking about the initial height?
Because it says release.
Released. Okay, so you just gotta read things carefully and think about, based on what you read, which category does it actually fit into? Okay, then part 2, it's asking what is the maximum height of the ball? In that case, what value of the equation am I looking for?
Vertex.
The vertex. Right, we got our maximum. That means I'm looking for the vertex, but what form is my equation written in?
Standard.
It's in standard form. So what am I gonna have to do?
Do the vertex formula.
The vertex formula. Yes, vertex formula. Okay, so let me move my little drawing up here. Since all I have is a standard form equation, I don't have a graph, I don't have vertex form, I have standard form, I'm gonna have to use the vertex formula. There's no other way. So what is my vertex formula again?
H equals negative b divided by 2a.
Good. All right, based on my equation, what is my A, what is my B?
Our A is negative 16, our B is positive 20.
Beautiful. All right, let's go for it. Plugging everything in. Now, if you're not writing this down, you're doing yourself a disservice. Please write this all down, because when you write things down, it's going to become easier and easier to remember how to do it. So after today, at this point, everyone should feel good about using the vertex formula all on their own. And at the end of, by the time we get to the end of class, I'm going to have you guys doing it on your own a few times. So let's do this one together. So negative 20 over negative, what?
32.
32. This is a calculator problem. Calculators are allowed. So go ahead and use your calculator. What do you get? Negative 20.
0.625.
Good. Now, this is my h value. When I look at the question, am I looking for the h value or the k value?
H.
It's asking for maximum height,
Okay.
k value.
So we need to plug that in.
We have to plug that in because, and let's think about this actually, let's think about this logically. Would it make any sense that that ball would only be traveling 0.625 feet in the air?
No.
That
It
would
needs
not
to be
make
a
sense.
fraction.
Yeah, that wouldn't make any sense. So this is 0.625 what? What are the units?
Units?
0.625 what? Chickens? Airplanes? What are they?
Seconds?
Seconds.
Oh.
Not feet, not feet. Because remember, would that make any sense if this is the vertex, right? If this ball was only going 0.625 feet in the air, then maybe it was thrown by like a toddler or someone really small, right? 0.625 feet, that would be a ball doing this. Okay, so that wouldn't make any sense in this case. So if you think about it, it's not feet, it's seconds. Okay, that's my h value. And now I have to take that number and I'm going to plug it in back into my original function equation. So let's go ahead and do that. So f of t, I'm going to do f of 0.625 equals negative 16 times 0.625 squared plus 20 times 0.625 plus 4. What operation do I do first?
Exponents.
Exponents first. So 0.625 to the power of 2. What do I get?
0.390625.
Okay, big number, right? Write it all down. 0. What did you say? 30?
39
Mm-hmm.
06
Mm-hmm.
5.
25. Okay, don't be afraid of these long decimals. We're using calculators anyway, so it's fine. And then what's 20 times 0.625?
12.5.
12.5, and then plus 4. All right, and then finally we need to do this. Negative 16 times 0.39065.
Oh, negative 6.25.
Perfect. So we have negative 6.25 plus 12.5 plus 4. Again, use your calculator. Make sure you use your negative sign carefully. So it's negative 6.25 plus 12.5 plus 4. What do we get?
10.25.
You got it, 10.25. And what are my units now?
Units? Oh, 15 feet. I mean, feet.
Feet. So the maximum height of this ball is going to be 10.25 feet. So my vertex is 0.625, comma, 10.25. So it reaches a maximum height of 10.25, and how long does it take to get to the maximum height?
0.625.
0.625 seconds. So this is this is a very typical type of problem. They give you an equation and it represents a scenario in the real world, and they'll ask you a question and you have to know, what am I looking for and how do I find it? So if it's asking you for the y-intercept, okay, you can just look at your equation. But if it's asking you for the vertex, then you're going to have to use the vertex formula to figure it out mathematically. Because when you're in standard form, all you know is that this is the y-intercept. That's all you know. So we have to use math to figure everything else out. Questions on this whole problem, take a look at it, see if there's any numbers you're not so sure about or any part where you might have gotten a little lost. We're going to do another one that's very similar. Yeah, so here's one question. After you get the h value, so remember this was my h value, you're always going to plug that number into the original equation, the original function. So all I did was I used this function right here and I plugged in 0.625 and then I had to do all that math. And that's exactly what you do. So in the end, we got the k value. All right. All right, we're going to do another one. It's very similar. Very, very similar. Okay, so, and we're going to do this one together again. This time, a ball is dropped out of a window of a building. The ball's height in feet can be represented by the function h of t equals negative 16t squared plus 48, where t is time in seconds. How many feet off of the ground was the ball released?
48.
Yeah. So I kind of asked that question without explaining anything, but let's look at what's different about this equation.
It doesn't have a b.
It does not have a b. How can you tell if this number is the b or the c?
The b has a variable. It's a coefficient.
Yeah. So let's go back to this problem real quick. The b always has a variable with it. So in this case, b was 20 because 20 has that t. 20 is a coefficient. But the 4 does not have a variable. If a number does not have a variable, it's not a coefficient, it's a
Y-intercept.
It's the y-intercept, but it's also called a
Constant.
constant. Yeah. So negative 16 and positive 20 are both coefficients, but the 4 is a constant because it does not have any variables. Now here, negative 16 is my a. So a is negative 16. There is no b, but there is a c, which is 48. So c is still the y-intercept. That is still the y-intercept right here, 48. Which means how many feet off of the ground was the ball released?
What was the question again?
Oh, I was just asking this same problem. We're still looking at the y-intercept, which is
Oh, 48.
48 feet. All right. Questions on that? Even though this equation is a little different, we're still looking at the constant value in order to find the y-intercept. Now, maximum height. Here's the same type of question. Do I know the maximum height just by looking? Do I know just by looking at my equation? What type of equation is this? What form is it written in?
Monomial.
It's not monomial, actually.
Oh, it's standard. Oops.
It's a binomial, but it's in standard form. It's in standard form. So do I know the vertex?
No.
No, right? Because it's in standard form. So we got to figure it out, same as before. H equals negative b over 2a. But what's the value of b?
0.
0. There is no b value, right? We don't have a, oh, my bad. Sorry. What the heck is going on? Okay, later. No one look at my password. I don't think you can anyways. Okay, we're good. Sometimes it just glitches on me like that. Okay, hopefully it didn't delete everything. No, we're good. All right. So we don't have a b value. It's not there. So when it's not there, we know that it's actually 0. So b equals 0. So when I plug it in, 0, and then a is negative 16, I end up with 0 over negative 32. But what's 0 divided by anything?
0.
It's still 0. So the h value is 0. And we'll talk about what that means in a moment. But what do you do after you find the h value?
Plug it in.
Plug it in. Plugging it into the original equation. But what happens here? What is 0 to the power of 2?
0.
0. And what's negative 16 times 0?
0.
Also 0. So what's my final answer?
48.
48. So k equals 48, which means where's my vertex?
Our vertex is at origin?
Not at the origin,
No. At
On the y-axis?
y-axis. No, no.
on the y-axis, yeah.
Oh, okay, okay.
Yeah, yeah.
It's the y-intercept.
It's the y-intercept, yeah. So the y-intercept is 0, 48, and the vertex is also 0, 48. So what's happening in this example, and if you read it carefully, you might have noticed this before, but read it carefully. What do they say about the ball? It's being, there's a key word, it's being dropped out of a window.
Oh.
So think about it. If I'm holding a ball and I just drop it, is it going to go up at all?
No, unless there's
Right.
some magic pulling on it.
So I have my pen here. If I just drop it, it's going to go straight down. It's not going to go up at all. So let's look at the previous problem because it's a little different. In this case, what are they doing to the ball? Is it dropped or is it something else? Tossed, yeah. Tossed. When you toss something, unless you're a toddler who doesn't know how to throw things yet, when you're tossing something, usually you're going to toss it up and then it comes back down. So that's a really good word to look at in each of these problems. I think this one, yep, the ball was thrown upward, right? So in this, all of these, it goes up, then it comes down. Here it's tossed up, then it comes down. But here, it's just dropped. So what happens is the y-intercept is 48, right? So let's say this is 48. And we're just throwing it straight down. It does not go up. So for that reason, the vertex is the same thing as the y-intercept. So this is kind of what we were talking about before at the very beginning today. In this case, what is the maximum height?
48.
48. What is the initial height?
48.
Also 48. But it only happens when b equals 0. So I'm going to write that down at the beginning, at the top, I mean. This is something you can write down as well. When b equals 0, the vertex is the same as the y-intercept. All right, so that's a big, big clue. If you see an equation like this where there is no b, then you know that the maximum height is the same as the initial height. So take a moment, write it all down, see if you have any questions. Anybody still writing? Anybody have questions? All right. All right, let's try one on your own now. So take a look at the problem. I'm not going to give anything away. Try it on your own. I'll give you guys about 4 minutes, though you probably won't even need that long. Go ahead and get started. 4 minutes. Okay, about 2 minutes left. All right, 1 minute remaining. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, so let's start things off. Part 1, how many feet off of the ground was the object released? How many feet off of the ground was the object released? What is this telling me to look at? Where am I
The
looking? Okay, the y-intercept. Where is the y-intercept of this equation?
144.
144. That is my y-intercept. Which means that it was released at 144 feet. Okay, this is very similar to the previous problem. Very, very similar. Okay, now what is missing from this standard form equation?
A B.
There's no b, right? No b, which means what happens when there's no b? What happens?
Vertex
The maximum.
at the y-intercept.
Good. So we can say it two different ways. The vertex equals the y-intercept. Or I think Lauren was saying it this way, the maximum equals what?
The y-intercept.
And the y-intercept represents the what?
The starting point.
Starting
Initial.
point. Initial, yeah.
We have to be fancy in this class.
We got to use those key words in this class. So yes, so the maximum is the same as the initial, which means that the maximum height is going to also be, it's also going to be 144. Because what is happening with this object? Are we throwing it, tossing it, or are we just dropping it? Look at the problem.
Drop.
It's dropped. It's dropped. So you can think of it like, oops, let me draw a picture because it's always helpful to see it.
It's half a parabolos.
Parabola.
Oh,
Parabola, yeah. It's half of a parabola. That's a good way to think about it, yeah. So you can picture like, I don't know, someone's on a cliff maybe, 144 feet, that's kind of high up. Somebody's out on a cliff somewhere and they found an object and they were like, let's just throw this off the cliff. Let's see what happens. They didn't throw it up into the air, they just dropped it straight down to the ground. So the maximum height is the same as the y-intercept. Now you could have done this by plugging it into the vertex formula, but if you did that, what would you end up getting? What's the value of b?
the value of b is 0, and if you continue with the formula, it will equal 0 at the end because something divided by 0 is 0.
Yeah, anything, 0 divided by anything is still 0. So you get h equals 0, and then if you plug in h back into the original equation, you also end up with 144, because this would be 0 plus 144, 144. So you end up with the same answer, long story short. So do I have any questions at this point on how to identify this type of scenario? That, remember, it doesn't always happen this way. This is only when there's no b value. Okay, when you don't have a b value, it's easier, right? Because the y-intercept is the same as the vertex. Any questions on that? Okay, cool. All right, now I have the same exact problem, but I'm going to add one kind of new thing to it because we've been talking about y-intercept, we've been talking about vertex, but which part of the function have we kind of skipped so far?
The B.
No, we talked about b before. We had b's a couple problems ago. But we've been finding the y-intercept, we've been finding the vertex, but what haven't we looked for yet?
The X.
The x-intercepts, yeah. So don't forget, those are still part of what we know about. So here's part 3. The function can be factored, we'll talk about that in a minute, to create an equivalent function h of t equals negative 16 times t plus 3 times t minus 3. Based on this, for how many seconds did the object fall until it hit the ground? So basically they said, okay, we take this original function. What form was this originally in again? What form is that?
Standard.
That was standard form. And they turned it into an equivalent function. And what form is this one in?
Factored?
That's factored form, yeah. It's in factored form. So they rewrote it a different way. Okay, these are equivalent. They are the same equation, just written different ways. One's in standard form, the other one's in factored form. So now that I'm in factored form, what can I find about this graph?
The
The two x's.
The what?
x-intercepts.
X-intercepts, good. So quick review on factored form. What do I do with my two factors?
You do t plus 3 equals 0 and t negative 3 equals 0, and then you add 0 for add 3 for
Mhm.
t equals 3, and then t equals 3, and then on the other side, oh, oops, I made a mistake.
That's okay. So we add 3 on this side, and on this side, what do I do?
No, I was talking about the left side when I was adding.
Oh, but what should we do on the left side?
Subtract.
Subtract 3. So t is negative 3 and positive 3. Now let's talk about what that means. These are my what?
Zeros.
My zeros, my x-intercepts. And if I was going to graph this, let me do a quick sketch. I know a few things now, right? I know that the y-intercept is 144. And then I know that the x-intercepts are positive 3 and negative 3.
Oh, so our y will be the AOS, which is the
Mm-hmm. Yeah, the AOS is down the y-axis. So this is going to go up and then boom. Now, what's wrong with this side of the graph?
is being
dotted.
reflected.
I made it dotted for a reason. Why did I make it dotted?
Because a foot can't be negative.
Yeah, so this is negative. This is we're measuring time over here. And we're not going to have negative time. That's not possible in the real world. So even though there are two x-intercepts, one of them works and the other one, there's a word that we learned yesterday. The other one is
Not viable.
not viable. Good. Not viable.
It will be a half parabola.
Parabola. Yeah. So only this part of the graph makes sense in the real world. The other part of the graph does not make sense in the real world. So now let's answer this question. For how many seconds did the object fall until it hit the ground? Remember, this is 3.
3 seconds.
Yeah, 3 seconds. 3 seconds total. Because we didn't start over here. Where did we start?
We started at 0.
At 0. Okay. So from this point where we begin to this point where we end, that's 3 seconds. We're not counting the other half of this parabola. We don't count it. So that's how we do it if you have factored form. Think about it for a moment. If you haven't written it down, write things down, and we'll do a few more examples. Any questions? Anybody still writing? Okay. Let's do another one. This one is kind of a long problem. I would love for somebody to read this one so that I don't have to. Who can
I'll
read it?
read.
Okay, go ahead.
Mountain lions are capable of jumping high into the air. If a mountain lion jumps 9 feet off the ground and then comes back down, its height above the ground varies. According to the equation, h equals negative 16 squared plus 24t, where t equals time in seconds and h equals height in feet. The right side of the equation can be factored to get the equivalent equation. h equals negative 8t parentheses 2t negative 3 parentheses. What do the factors h, oh my gosh, negative 8t and 2t negative 3 mean in this situation?
Awesome. Okay, there's a lot of information in this problem. A lot of information. So they give us two equivalent equations. So we have this one right here, and then we have this one right here. The one that I highlighted in green, what form is that one written in?
Standard.
Standard form. Let's see if I don't have a lot of room, but I'll write it over here. That's in standard form.
Anything is capable.
And what is this one written in?
Distribution form.
That's not really a thing. So think about it. Think about what we know about so it's definitely not standard form, but between vertex form and factored form, which one does it more closely look like?
Factored.
Yes, because what does vertex form have
That
that,
factor
that
doesn't.
factored doesn't?
A square at the end of the parenthesis or.
Got it. So vertex form would have an exponent, but factored form never does. So I know that this is definitely, even though it doesn't look like our usual type of factored form, it's still factored form. Okay. And then it's asking me, what do these two factors, see, they kind of gave it away. They kind of said, okay, these are factors. What do negative 8t and 2t minus 3 mean in this situation? So I'm going to rewrite this equation down here. And let's just remember what factored form actually does. What does factored form tell me about a function?
It tells you the width and direction.
Okay, so this negative 8 tells me the width and direction. And then what do the two factors tell me?
The sides of the AOS or the x-intercepts.
The x-intercepts. The x-intercepts. So even though this one looks a little bit different than this type of factored form, we're still going to do the same thing, where we take each of the factors and we're going to set it equal to 0, and then we're going to see what we get. So here's one factor. Here's the other one. Okay, and we're just going to solve each one of these and see what we get for t. So I want everyone to try that on their own really quickly. I have to take a phone call from Mr. St. Rose, and then we'll go through it together. All right, guys, I'm back. So let's talk about this. So we're solving for t. Solving for t. So on this equation right here, if I want to get t by itself, what am I going to do to both sides?
Oh, wait. You have to subtract t.
We're not going to subtract t.
Add t.
We're trying to keep t on its own. So can anyone else think about how would I get t all by itself?
Oh, you have to divide.
Divide by 8, -8. Why am I dividing rather than adding? Because I think a few.
-8 and t are like they are bounded by multiplication, and multiplication, the opposite of multiplication is division.
That was a beautiful way of saying it, Jara. I love that. Okay. They're bounded together by multiplication. That's exactly right. So when I divide by -8, what is 0 divided by -8?
0.
0. So here I get t equals 0. So for this factor, my x-intercept is 0. Now for this factor, how do I get t by itself? What do I do first?
Divide everything by 2.
Not yet. There's something I have to do first.
Oh, this reminds me of the old days in September. Okay, so you have to add 3 to the other side.
Mhm. There you go. So 2t equals 3.
And
And Juan, I'll get to your question in a moment. And then what do I do?
now you can divide.
Now I can divide by 2. And what's 3 divided by 2? You can get a decimal since we're talking about time.
I remember we did this before. Is it 1.5?
Yes, it is 1.5.
Oh, by the way, Juan, the -8, I believe, is just the negative, and the t is just
T is still positive because 0 divided by anything, even negative numbers, is still 0. So since I divided by -8, 0 divided by -8 is still 0. Not -0 or -t. It kind of cancels out. So I have my two x-intercepts. Now let's think about what this means on a graph. I have one x-intercept over here at 0, and I have another one at 1.5. Let's say this is 1 and this is 2. So 1.5 is going to be like over here. So Juan, go on your calculator, type in 0 divided by -8. See what you get. That's I can't explain it any other way. 0 divided by any number, even a negative number, is still 0. Okay, so these are my two x-intercepts. And what's the shape of the graph? Is it facing upwards or is it facing downwards?
downwards.
Downwards. So the graph is going to look something like this. This is a mountain lion, right? It's jumping. And now take a look at the x-intercepts. On the other side, -8, I divided it by -8. So
Oh,
two
you think
negatives.
it will cancel out, but it will cancel out, like I think it will cancel out if it's -8 and then +8.
They cancel because I had -8 and I'm dividing it by -8. And a negative divided by a negative
Equals
is a positive. It's a positive.
It's going to be 1t, which is
Yeah, 1t equals 0. Does that make sense? Sorry, I keep going back, but
Does it, Juan?
okay, good. All right, so here we are. Take a look at your answer choices and let's see which one makes the most sense. In fact, which ones could I possibly cancel out?
C and D? Wait, no.
Why?
I'm sorry, I didn't read it correctly.
Oops. A and B, yeah. Why can I cross those out? What's wrong with those? No 8.
Yes,
Yeah.
don't equal 8.
Yeah, x does not equal 8. Or t does not equal 8. That's wrong. Okay. And then between C and D, which one makes most sense? Is it the maximum height at 1.5 or does it land at the 1.5?
Land.
It lands at 1.5.
It lands at 1.5. So it's answer choice D. When is the maximum?
The maximum's at the vertex, and the vertex. Wait, the vertex is 1.
Is 1 on the x-axis. But we don't know, I don't know how high it is yet. I would
Then
have to figure
it's
that out.
24 on the y-axis.
No, don't be fooled. That's not the vertex.
Oh, I'm sorry. Oops, I didn't.
That's okay. If you wanted to find the vertex, what would be the only way to do so?
The vertex.
Hmm.
Mm.
I have standard form right here. What would be the only way to find the vertex?
Turn it into vertex form.
Don't turn it into vertex form. We can use the
Vertex formula.
vertex formula. H equals negative b over 2a.
Well, y
That
is
right
0.
at this point.
Y is 0, right?
Y is 0. What do you mean by that? Oh, the y-intercept?
Yeah, there is no
Yep.
y in the
Yeah, the y-intercept is 0 as well because it starts at 0, 0. So the x-intercept is 0 and the y-intercept is 0 at that point. Because there's also no c. There's an a, there's a b, but there's no c. So that means the y-intercept is 0. So see how all of these things, they come together and to create one big picture, but you need both. Like just from standard form, I don't get the full story. Just from vertex form, I don't get the full story. Just from factored form, I don't get the full story. But when you start putting them together, you can get a good full picture. Okie dokes, moving right along. Let's try this one. So here's an interesting one. I kind of want to do this one together because it's a little bit more challenging. The height of a rocket is modeled by h of t equals negative 4t minus 12 times 4t minus 36. How long after reaching its maximum height does it take for the rocket to hit the ground? So what form is this in?
Factor.
Factored. What does factored form tell me about an equation, about a function?
It tells you the zeros.
The zeros. So let's do the same thing we've been doing. I'm going to take each factor, make it equal to 0, and then we're going to solve. What should I do to both sides of this equation?
Add.
So I have 4t equals 12. Now what can I do to both sides?
Divide.
Divide by 4. What's 12 divided by 4?
3.
3. Now on the other hand, what should I do to both sides here?
Add 36.
Mm-hmm. And now?
You divide by 4.
Good. 36 divided by 4 is
9.
9. Good. All right. So these are my x-intercepts. So this question is going to be a lot easier after I draw a little sketch. Because I know where my x-intercepts are. +3 and +9. So let me 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's one. Here's the other. And what direction is my graph going? Upwards or downwards?
Downwards.
Facing downwards, right? So I know that whatever is happening is going to look something like this. Right?
Mm-hmm.
It's a rocket. It's going up. It hits a maximum. Then it comes down. Where is the maximum?
At 6.
Good. How do you know that?
Well, I counted from 3, 1, 2,
Mhm.
3, 6, and then I counted backwards from 9, and then it equals the same distance.
That's the thing we got to remember. So we kind of went over this earlier this week. But don't forget that the vertex is located at the middle between the two x-intercepts. So if this is 3 and this is 9, what number is right in the bit in between those two? Which I already said. This has to be the number 6,
6.
right? So based on that, now we can answer the question, how long after reaching its maximum height does it take for the rocket to hit the ground?
3 seconds.
3 seconds. So after reaching its maximum height, that rocket's going to drop for a total of 3 seconds. How long is the rocket in the air for in total?
In total,
Mm-hmm.
so 1, 2, 3.
In total, how long is it in the air?
Oh.
Not 12 seconds.
6. Well,
6.
Is it 6 seconds?
Yeah, because where does it start going up into the air?
So 3, and then if we count 1, 2, 3, 4, 5, 6.
6 seconds. You can also do 9 minus 3, which gives you 6 as well. So this is the total time it's in the air is from 3 to 9. That's 6 seconds. But it goes down, so it goes up for 3 seconds and then it comes down for 3 seconds. That's how it works. So even though all I knew was the two x-intercepts, when you have the x-intercepts, you can always figure out what the middle is, and that's going to help you find the h value of the vertex. So the vertex is at 6 comma something. And we don't know what that value is unless we plug it in and figure it out. Any questions on that? So that was something that we kind of talked about last week when we talked about factored form, but I definitely wanted to bring it back because sometimes it comes back in a word problem type of scenario.
Wait, why did we pick A again?
Because it was asking how long after reaching its maximum height does the rocket take to hit the ground. So it goes up for 3 seconds, it reaches the maximum height, and then it's going to go down for 3 seconds.
Oh, okay. So then after the maximum, we start from 6 now, and then we count all the way.
Exactly. Exactly. All right. Questions. I know that we're really putting everything all together now. So today, this is the last thing we're actually going to be learning. After today, it's all review, but that's why today's class is just kind of putting everything together. All right. Now, I just want to go back to this one for a second. Oh, actually, no, never mind. We're good. All right. Let's see. I think we have time for one more. Let me find a good one to use. No, not this one. Oh, this one's good. Okay. So here's our last question of the day. The height of an arrow shot from a bow in an upwards direction, I'm going to highlight that because we know what that means. So it's going up and then down, not straight down, is modeled by the function f of t equals negative 16t squared plus 96t plus 5, where t represents the time in minutes. During which interval is the arrow going up? So, real quick, let's do a little sketch. Because what do we know based on my equation? What form is this
The y.
equation? We know the y-intercept, right? This is standard form, so I know that the y-intercept is 5. And is the graph going upwards or downwards?
Downwards.
Facing downwards.
I got confused when you highlighted upwards. I thought it was the equation.
Oh, yeah, that's a good point. So it's not that the parabola is facing upwards, it's that the arrow gets shot upwards and then it comes back down. So 1, 2, 3, 4, 5 right here. I know that this arrow is going up and then coming down, right? Now, what is the question asking me? The question is asking me, what is the interval during which the arrow is going up? So from where to where would the arrow go up? From which two parts of the graph?
From 3 to 6. No, wait.
Be less, I don't want numbers, just tell me from which 2 points of the graph would the arrow go up?
Oh, okay. Well, it starts at 5.
Mm-hmm.
It has to go up to the AOS.
To the vertex or the AOS, right? So this is my vertex. So this part of the graph, from here to here. Do I know where this vertex is located?
No,
I do not. How do I find it out?
you have to do the vertex formula.
Vertex formula. So let's do that real quick. One more time before we go for today. So h equals negative b over 2a. What's my b value?
Positive 96.
96. What's my a value?
Negative 16.
Negative 16. And what is negative 96 divided by negative 32? You can use your calculator. It's 3. So h equals 3, which means the vertex is at 3 comma something. But the important part is that we know that this is 3. So from what time, from when to when is the arrow going up?
0 to 3.
0 to 3. Answer choice A. Remember that when it's asking about an interval, intervals always talk about time.
So it can't be equal to because time does not stop.
Yeah, you can't have an equal to sign, so it's not going to be C or D. But also, it was talking about when it's going up, so we know that it starts from 5 and it goes up from there. So whichever, even without knowing the value of the vertex, we could have chosen the right answer because it's going to start at 0, from 0 to 3.
Even though the height starts at y, doesn't like specific.
Even though the height starts at 5, that's not what it's asking. It's not asking for the height, it's asking for the time interval. The time interval. So that's what we were looking for. 0 to 3.
It looks
Which
like
means
a little bed.
A what?
Your line looks like a little bed.
Oh, yeah, it does. So for that reason, it's answer choice A. All right, y'all, we made it through most of them. I'll do some of these maybe tomorrow. As a quick
Very good.
reminder, all extra credit work and all makeup work are due tonight at midnight. If you have any remaining Khan Academy or any remaining Teams quizzes, or if you want to do the extra credit opportunities, which I've already posted, everything's on Teams. So if you're not sure where to find this, go on Teams. All of that is due tonight at midnight, and that's it. Tomorrow I'm submitting all the final grades, and that's it for this marking period. So just make sure that if you still have anything you wanted to get done, you get it done tonight. Are there any final questions before we go?
Not really.
Not really. Alrighty, y'all. Have a nice day, and I will see you all tomorrow.
See you tomorrow, Miss Lopez. Have a nice day.
Thank you. Bye, guys.